welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice. Today I'm joined here with co-host Pavel, who is DevRel lead at ZKM, and our guest Amrit, who's COO at AltLayer. Thank you so much for being here, Amrit. Really excited to have you here today.
Thank you very much. Excited to be here.
Yeah, thank you. I'm wondering, Amrit, if you can first start off with an introduction yourself, like how you got involved into the Web3 and then also ZK spaces.
Yeah, sure. So, I was doing my PhD in France. I was exploring and working on, applied cryptography. So protocols like private set intersection protocols, private information retrieval protocols, and so on. And this was the time when I was just about to finish my PhD, and I had probably 2 or 3 months left, to be honest. And so I asked my advisor. This was the time when Bitcoin was becoming, this was about 2013, when Bitcoin was becoming really interesting for academics. Up until then, it was like, it's their thing. We'll see at some point if it's interesting enough for academics. But at that point, it was changing. Quite a few people in academia had started to publish interesting papers around Bitcoin. And I felt like, okay, maybe I should do something as well. So I asked my supervisor if I could find a project in Bitcoin. He said, you're nearly there, it's finishing, we can't fund you and so on. And so I had to stick with whatever I had. But then I knew that I would like to do something around this. So I started looking for a postdoc. And at that time, this was about end of 2016, so when ICOs were happening. And there were 2 countries that were very popular for ICOs. One was Switzerland, because a lot of foundations were set up in Switzerland. And the second was Singapore. And so I felt, okay, I should try one of these places. And then I landed in Singapore. Unfortunately, I didn't join any crypto startup. I went on to join a university in Singapore called NUS, National University of Singapore. But this is where a lot of activity was happening in Singapore. So Vitalik used to frequently visit the university. He was basically doing all the early stage of Ethereum groundwork and grassroots work. He was hiring interns and people. So there was a guy called Loy who was in the lab at the time. He was interning with Vitalik at the time, and then he later founded Kyber Network, which was, I would say, one of the first DEXs before Uniswap. So I joined the lab, and then unfortunately my advisor said, "Oh, it's too late. You're too late to the party. There's nothing interesting to do anymore. Maybe you should do machine learning." So he forced me towards machine learning for a bit. To be honest with you, I didn't like it. Now that all the AI agent hype is coming up, it feels like maybe I should have spent some time back then. But then I persevered, and then I started looking into Monero. This was the time when Dash was there. Zcash had just launched. And so I felt, okay, maybe I should look into Monero. So I started digging into it. So my first venture into blockchain space was Monero. So I read Monero's white paper first, then went back to understand how Bitcoin worked. And this was again the time when mixers were heavily popular, all sorts of mixing designs were being put out in the Bitcoin space and even beyond. And so we published a paper on Monero, and then later on I started, me and some of my colleagues from the lab, we started a company called Zilliqa, which was a layer 1 blockchain with sharding built in. And then in 2021 I left Zilliqa, and then we started a company called AltLayer, where we started off as a RAS service. So we help people deploy rollups. But then we have also been doing all sorts of other things beyond rollups. So that's kind of a quick, short summary of what I've been doing in the last 7-8 years.
Nice, and really like how you had all of those experiences very early on. Like, for example, your first exposure to Bitcoin was back in 2013, and then you saw like the early stages of the Ethereum groundworks being built up back when you were in Singapore. I think that's all very, very cool. So thank you for that. Curious to hear about your perspectives on the current stage of rollups. So what you're working with in AltLayer right now. Curious to hear what your thoughts are surrounding the biggest challenges on general purpose rollups, and maybe some of the other challenges that come with the rollup-centric roadmap.
Yeah, sometimes I feel very weird about this rollup space, to be honest, because there was a time when we, as a Ethereum community, or any other purist community, you could call it, we didn't like EOS, for example. We didn't like Neo blockchain. We didn't like many of the other blockchains that were coming up in back in 2016, 2017. And one of the reasons where, hey, this system is not secure, it's not decentralized. You have 5 nodes or 10 nodes or 20 nodes and so on. And so when I started to look into rollups, they were actually worse than EOS. They were worse than some of the chains that Ethereum community didn't like or hate. Things have changed ever since. For example, for a very long time, Optimism didn't have fraud proofs, which meant that basically it was running as a sidechain, a single node sidechain, essentially. Yes, there were all sorts of social construct to prevent issues and security issues, but in the end, at the protocol level, there was nothing. And some people were asking, okay, if there's no fraud proof, why there's a withdrawal period of 7 days or 14 days? What was the point of it? And so, to be honest with you, I was initially disappointed to see why Ethereum community accepted these kind of designs from the very beginning. They were kind of okay with it. So that is kind of why I guess Vitalik came up with this idea of stage 1, stage 0, stage 1, and stage 2, kind of to define what kind of risks you are taking when you are using or building a certain rollup because of those missing pieces that were essential for rollups to be secure. So I would say, yeah, I was initially disappointed, but yeah, things have changed. I certainly have to give a lot of credit to Arbitrum, for example. They were, from the get-go, making sure that every single piece that is needed to make sure the rollup is actually secure and to be actually called a rollup is actually there. So Arbitrum definitely did that. And a couple of other chains like Fuel had some of these, all these main features there. And so it was really interesting to see some of these chains doing things properly, while others were kind of a bit lagging behind the scenes, I would say. So that's kind of, I would say, my high-level overview of why I feel like, generally speaking, we could have done better, as an Ethereum community. We should not have accepted these things that we feel like it's okay to leave it for the future. For example, fraud proofs and so on. Anyway, so this is, I guess, the general state of rollups, where rollups are not. Yes, and fraud proofs are there, but then again, even in Arbitrum, you have fraud proofs, but they're still building this mechanism called Bolt, which is a permissionless fraud proof system where anyone can come in and commit state proofs, or anyone can come in, go and challenge. That's still being built. It's on testnet, but it's not live on mainnet yet. So I would say we're still in the stage where most rollups are not fully ready in that sense of it. Not fully decentralized, not fully secure in that sense of it. But we're getting there. So that's, I guess, the technical aspects of it. And the second thing, which I guess a lot of people argue, especially people from Solana ecosystem, is that it has created this huge divide of or fragmentation of liquidity. And by what I mean by liquidity is not necessarily financial liquidity. Of course, funds are moved, some part of funds are sitting on Base, some are sitting on Arbitrum, some on Optimism, but there's also a user fragmentation as well, right? Which most people don't talk about. And that has also affected, this is kind of what a lot of people give when they talk about, hey, Ethereum's rollup-centric roadmap is probably not the most ideal roadmap that Ethereum may have taken. And one of the considerations is users, right? Users are moving away from Ethereum to some of the chains like Arbitrum, Optimism, and some people say, hey, is it a good thing? Or is it how it was supposed to happen? But I do feel like there's a narrative that Ethereum is losing in some way because of this. Losing in terms of users. In terms of TVL is still one of the biggest chains out there. But in terms of users, there has been impact. And there's a debate around whether it was intentional or it was something that the rollup-centric roadmap didn't consider from the get-go.
Got it. And thank you for mentioning that user fragmentation within the fragmentation of liquidity as well. I feel like that's not spoken enough of, so appreciate you for mentioning that. And also wanted to talk a little bit, you mentioned about the different stages that were created, like those kinds of points of risks when you're building a certain rollup. So just wanted to hear your perspectives on where we stand today and what needs to be implemented for these rollups to be migrated to stage 2 and later stages as well.
Yeah, so for the context, for those who are not very familiar, so Vitalik proposed this, I think 3 years ago, 2 or 3 years ago. And then L2 beats basically formalize them as a framework for people to understand what kind of, how secure, how decentralized, and what are the risks that you're taking when you're interacting with a certain rollup. And so there are basically three different stages. So stage 0, stage 1, and stage 2. Stage 0 is basically, if I recall correctly, basically it says that as long as you call yourself a rollup, you're a rollup. That's kind of what stage 0 basically means. So you don't necessarily need to have fraud proofs. You could basically be running everything with multisigs. And that's kind of what optimism, for example, was for a really long time, stage 0. Stage 1 is where you assume that there has to be a fraud-proof system. So this is stage 1. So that's a bare minimum requirement. And then there's a requirement that if you want to do upgrades around the rollups, so for example, your bridge, your sequencer contracts and whatnot, you need to have some sort of a security council composed of different participants, and there's like a requirement of what should be the threshold of that, so 5 out of 9 or something like that. So there has to be a sufficiently large number of people who should vote to be able to upgrade some of the base contracts necessary for the rollups to be operational. And stage 3 is where, so this is where, stage 1 is where you have some training wheels that are needed to make sure that the system actually operates correctly. And third one is stage 2, which is where you don't have any of those training wheels. So you have a security council, you have, of course, permissionless fraud proof. So anyone can come in and challenge or push state roots and so on. And then there is a security council, but the purpose of security council is not to push upgrades, but to adjudicate between any bugs that may happen. So for example, let's say you are a ZK rollup, and let's say, for example, for whatever reason, ZK rollup, your proving mechanism had a bug. And so it basically it actually creates a proof, basically an invalid proof, that says that, hey, this transaction or this block was valid, but in fact it was not valid. And so if the proof was buggy, you need some external system, some external social layer to prove that, hey, this was wrong, and the only way you can fix it, because you cannot do that at the protocol level anymore because the system itself is buggy. So you need some sort of external intervention, and that would be through the Security Council. So the difference between stage 1 and stage 2 was that you have to have permissionless fraud proof in stage 2, and the Security Council's powers are quite limited. So they cannot make upgrades, they can only decide on, let's say, bugs that may happen. Now, when you think about bugs, how do you know that this is actually a bug, right? And for that to happen, you need to have at least 2 different implementations of the same system. So same state transition function. So for example, let's say if you have an optimistic rollup, so you need to have, let's say, one fraud proof and then potentially one, let's say, TE proof or a ZK fault proof, so something that goes alongside your main proving system. And if you see that there's some sort of a disagreement between these two, this is where the Security Council comes in. And so basically, stage 2 assumes that at least you have 2 different implementations of your state transition functions. Without that, it doesn't work. So yeah, these are 3 frameworks or 3 different categories that Vitalik and L2Beat, I guess, formalize them. But obviously it doesn't stop there. You could imagine stage 3, for example, which is, by the way, it's not covered in any of these stages, which is, for example, sequences. How do you make sure that the sequences are actually decentralized? How do you make sure that you completely get rid of Security Council at all, right? It could work like traditional blockchains like Ethereum, where you have this social consensus over forks. So if there's a bug, if there's a disagreement, then the social layer will kick in, and then the social layer will decide which one is the legit one, which one is the canonical chain. And so you could completely get rid of a Security Council in this case. So that could potentially become stage 3. By the way, it doesn't exist quite yet because people are still building stage 2. I think there are probably 2 maximum, 2 chains that are stage 2. Most of them are stage 1, including Arbitrum, Optimism, and the others. So people haven't gone beyond stage 2 quite yet. So yeah, I would say most rollups are still in stage 0. Only couple, maybe 3 chains are in stage 1. And stage 2, and then nothing, of course, in stage 3.
Do you think that having a decentralized sequencer set would improve the security of stage 1 and 2? I would say, do you need to have a working fraud-proof system in order for stage 3 to be relevant in terms of its security properties?
I would say if you're optimistic rollup, your fraud-proof system has to be there. Without that, the system just doesn't work. Simple as that. Because without fraud proofs, you're basically assuming that this chain, whether it's run by centralized or decentralized sequencers, you are trusting it as a side chain to the base Ethereum, because there's no way to actually check whether the rollup is actually operating correctly. And the only way you could do this is through a fault proofs or validity proofs. So I would say that is absolutely essential. Sequencers, and for those who don't know this list, even if you have a centralized sequencer, it doesn't impact the security of the system. What I mean by security is, okay, let me break down security. So there are two components when you talk about security of a system, which is it's about safety, which means that your funds are not at risk, you cannot double spend and those sort of things. And second component is liveness, which is my system actually running, right? Imagine a system which is super secure, but is just not available for anyone to use. What's the point of that system, right? So you want to make sure that at least the system is available for people to interact and use. And so decentralized sequencing helps you with liveness, but it doesn't necessarily help you with safety. Safety comes from fault proofs, validity proofs, and those two are the one that gives you that guarantee. Centralized or decentralized sequencer doesn't really impact you. What they really do give you is availability. And by the way, we have seen that in the past, where I think about a couple of years ago, Arbitrum sequencer was down several times actually, and because of AWS outage or so on. And when that happened, users couldn't send transactions to Arbitrum for quite a long time, so a few hours. So that is what could have been solved with something like decentralized sequencing. But even if you had decentralized sequencing, without fraud proofs, nothing is secure.
Got it. And on this topic, you mentioned that decentralized sequencing does help with liveness, but not necessarily those like safety guarantees. Also curious to hear if there's any other kinds of risks or drawbacks for rollups transitioning to this to a decentralized sequencer set. And for AltLayer specifically, I know that you guys are adopting this, and curious to hear about on AltLayer's side what the developer experience looks like when you're, say, trying to set up a rollup with decentralized sequencers.
Yeah, so I mean, there's several downsides of decentralized sequencing, and that's kind of the main reason why people went with centralized sequencing in the first place. And but if you go back to rollup design, the first design that came up with rollups, they didn't assume sequencers at all. There was no notion of sequencing. So the assumption was that you post transactions on Ethereum, and from there on, someone can take those transactions and then compute the state and commit that state on chain. And then people realize that this is not very efficient because you have to rely on Ethereum, and you have to post transaction on Ethereum, and you have to wait for Ethereum's block to finalize and so on. And so people felt like, okay, maybe a better way is to send those transactions to a centralized sequencer that can process transactions much faster. So I would say centralized sequencer was not the first design. The base design was like the base sequencing, the way Justin calls it now. So we are kind of revisiting the whole thing back again. So I would say one of the biggest downside of decentralized sequencing is latency. If you look at any of the decentralized sequencing, let's say, network that's out there today, whether in testnet or mainnet, for example, let's say Espresso or the likes, they need to reach consensus on, at least in the initial design of the consensus protocol that they were running, that you have to send transactions to them, and they will basically run a consensus protocol on that block to agree on the order. And this will introduce a latency because you have a consensus protocol that's going to take some time to finalize. And it can take anything between 1 second to up to 4 seconds, depending on what your protocol is. And then that order transaction has to be executed by someone, because that entity or that user has to then commit that state on chain, right? And then everyone would know that this is the final state. And then again, that would take maybe another 1 or 2 seconds. So it's quite likely that if you're using a decentralized sequencer set, especially with a consensus protocol, then your latency for block production is going to be much longer or much higher compared to a centralized sequencer. It's kind of normal to see that. Then there are designs where you have like a round robin design where you have like, let's say 5 nodes that are acting as a sequencer. And then one of the node gets selected to be your sequencer for a certain period of time. And they are the one basically ordering blocks for you. So there's no consensus per se, but it's like centralized, decentralized sequencing in some sense, right? It's decentralized, but it's centralized in the sense that there's like one node that's being tasked to order transactions. And there you could have a slightly better performance, in terms of getting latency. Now people are coming with base sequencing where you can actually use L1, validators or proposers actually to propose and order blocks for you. And if you use the vanilla design where there's no pre-confirmation or any way to actually give you an early guarantee that your block will be ordered in a certain way, then you have to rely on Ethereum's finality guarantees and Ethereum's latency, which is very, very slow. And so that's kind of why if you are using base sequencing, you need to have something else, which is the pre-conf gateway, or pre-confirmation mechanism to give you kind of a guarantee that's almost equal to the guarantee that you get from sequencer these days, where sequencer gives you this pinky promise saying, hey, we have seen your transactions, and at some point in the future, we are going to take your transactions and put that on Ethereum. And that's kind of the guarantee that you can get from these L1, pre-conf gateways, for example. So yeah, I would say the first major drawback is that latency. The second drawback is, which sometimes people discuss, but there are many ways around it, which is if you don't control the sequencing, then you may actually be losing MEV. That's one argument that people throw. There are ways around it. For example, like in case of base sequencing or even sequencing services that are proposed by Espresso, you can actually auction your block. So you could say, look, I have this block number 15 that I need to get ordered, and anyone that is going to pay me at least $10 will get the right to sequence the block. And why you set the floor? Because this is the minimum price the minimum money or revenue that you'd make if you were to sequence it yourself. So it basically tells you that if you don't give me more than $10, then I'm not going to give it to you because I would rather do it myself, and I would make that revenue, I'd generate that revenue myself. And so the idea is there'll be an auction mechanism with a floor price of your revenue as a centralized sequencer, and you say, okay, I'm willing to give it to anyone else as long as they give me more money than what I would have made if I were to run this in a centralized way. And so this is kind of what many people are building with base sequencing, but also with sequencing services or sequencing marketplaces like Espresso. So that's in one way downside, depending on how you say it, where you may or may not get the same MEV or revenue that you're controlling. But yeah, I would say the major downside is latency. But the major upside from all of this is, for decentralized or shared sequencing is interoperability. So if you're using, let's say, base sequencing or a shared sequencing like Espresso, your sequencer is shared across a bunch of rollups. And because that sequencer sees all those transactions across all those rollups, they can actually help you order transactions in a much better way and also help you interoperability. So I would say that's the major upside by having decent sequencer. And of course, the other upside is liveness. So you get better liveness than a centralized sequencer.
Got it. Thank you, Amrit. So latency we see as the major downside, but we also have some advantages with liveness, with interoperability as well. Okay, got it. And curious to hear also from AltLayer's side, you guys are building restaked rollups. So I wanted to hear more about what restaked rollups enable and how they compare to some other designs that we currently see, like for example with base rollups, in terms of their architecture.
Yeah. So. We started restaked rollups mostly from the feedback we're getting from our clients. So for context, we are as a RAS service. So people come to us and they say, hey, we want to have an OP stack rollup with these customizations. Could you help us do that? And that's kind of what we do. We offer that as a service. And a common feedback that we're getting from people was, hey, we have a token. How do I get our token used? And the obvious answer that we used to give them initially was, hey, you can use your token as a gas token for your chain. And then after thinking quite a bit about this, we realized that it was a bad recommendation, bad suggestion, because if you think about it, right, if you insert your own token as a gas token, you're introducing quite a few issues. One is UX issue, right? A user who has to come and interact on your chain or use your chain has to now acquire this your DApp token or rollup token, which can be painful. You could probably get around with this some sort of account abstraction or gasless or what have you, but still it's quite painful to actually put that in front of user. The second thing is, if your goal with this custom gas token is to drive token usage, it doesn't help you with that much, to be honest, because in the end it's a rollup. It's supposed to be very cheap in terms of gas fees. And so unless you are doing, I don't know, millions of transactions a day, then maybe you'll generate revenue from gas fees that'd be enough to be meaningful for you to put this as a gas token. Otherwise, it's like for most chains that's not going to happen. And so it's actually, if your thinking is that, hey, I'm going to put my custom gas token to actually capture value, that's most likely it's not going to happen. And the third reason that some people felt could be used was, the other reason why it's a bad idea is because in the end you're a rollup, which means that you have to pay Ethereum some fees, right, for transaction posting, for DA, or for settlement, and so on. And that has to be ETH. And so at some point you have to sell your token, the token that you acquired from users who paid in gas. You have to sell them for ETH and then pay to Ethereum validators, which means that there's always going to be a sell pressure on your token. Like there's a constant sell pressure on the token, which is kind of defeats the whole purpose of having a token, right, as a gas token. So, after careful thinking, we realized that was a really bad idea. And to be honest with you, people actually stopped asking about this after a while when they realized that it's actually not a good idea. And so we felt like, okay, how could you build a mechanism in which you could get your token used in some way? And so we came up with this idea of restaked rollups, where the idea was all these rollups, they're not perfect, right? We discussed about this, stage 0, stage 1, and stage 2. They're not all perfect, so there's always something that's missing. And so, for example, a decentralized sequencing could be a good option for you if you're looking for build a DeFi specific rollup and you want to have ensure that there's like a bunch of nodes operating and serving your rollup. You could also have a mechanism where if you wanted to get your community involved in some way, because rollups run by a RASP but is super centralized in the sense that there's no way for you to actually get your community involved in the operation of that rollup, right? So the idea was, let's say if you have a decentralized sequencer network, then you could say, hey, maybe I would bring Figment, which is one of my investor, or I would bring Polychain or Paradigm, what have you, right? You could bring them and engage them as a participant in your network as an operator. And so that builds a network rather than a closed vendor model that RAS services provide you. Now, once you have these nodes, then you need some sort of security, because you don't want these nodes to kind of do whatever they want. So there has to be some economic security. And this is where your token can get involved. So you could say, look, if you want to become one of my sequencers, then you have to stake some amount of my token, for example. And so it creates a bit of sync for your token. And it also gives you this additional benefit of, better liveness, better security in that sense. And so restaked rollups idea was to bring restaking from EigenLayer to rollups through that you'd build services like decentralized sequencing, faster finality, or for example, a decentralized challenger network, for example, for optimistic rollups. So yeah, that's a high level of what restaked rollups are. And the differences between base rollups are very different. Base rollups is purely for sequencing. You can use that for interoperability. But base rollups inherently doesn't give you the staking ability directly. The pre-conf gateway can do that. But I'm not sure if anyone has designed that quite yet.
Got it. Thank you. And also curious to hear more about the AVSs that you offer through the restaked rollups. So I know that you provide builders with the option to almost plug in the available AVS components into their restaked rollups, depending on whatever needs they're looking for. Curious about how that providing developers with that kind of choice, how that affects the whole experience. And also curious to hear about which scenarios would a developer use, say, one AVS over the other.
Yeah, so there are three AVSs under this restaked rollup framework. So the first one is called MACH, M-A-C-H, which is basically a fast finality AVS. And what it does is If you look at rollups today, you have to send transactions to Ethereum, you have to wait for those transactions to be finalized, and then you have to wait for any fall proof or anything to trigger, and then basically your state or the L2 block becomes considered final. And so one idea that we had was, and by the way, this can take up to 12 minutes, just the transaction settlement part. And so the one idea that I had was you could basically run a bunch of full nodes that are getting transactions from the sequencers and verifying themselves whether the rollup block looks good to them. And then they would attest that, hey, we have seen this transaction, we have rerun those transactions ourselves, and everything looks good to us. Here's our vote, or here's our signature. And based on that, and that could happen very quickly because it's kind of off-chain service, it doesn't touch Ethereum. And so with that, you can actually give you, these networks can give you faster finality guarantees from that. Of course, it's not the same as the guarantee that you're getting from Ethereum, because this one is purely crypto economic. So it gives you slightly better than what you get from sequencers, because now you have a bunch of nodes with economic capital there. And so that's basically Mark. It gives you faster finality. The second one is called Squad, which is a decentralized sequencing AVS. So you spin up a bunch of nodes, and then you decide how your blocks will be sequenced. So it could be round robin, it could be consensus, any mechanism that you would like. And then the block will get sequenced according to that. And the third one is called Vital, which is a decentralized challenger network. So imagine you want to have a fall-proof mechanism for your rollup, and you want to make sure that you have at least a couple of nodes checking for any invalid blocks. And if there's an invalid block that pops up, then this challenger comes up and say, hey, this block doesn't look good to me. Here's my challenge to this block. And so that's basically what Vital does. And so these are all modular in the sense that you can pick and choose what you want. So for example, let's say rollup might say, hey, we don't care about decentralized sequencing because we are just a gaming rollup. It's not super important for us. Then you could basically just rely on Mac, which is faster finality, because that's something that's interesting for gaming chains, because they want to be able to move their game logic quite fast in the UI rather than kind of waiting for transactions to be finalized. So that might make sense for you. If you are, let's say, a rollup that is very security centric or sensitive, then you say, oh, I actually want to have some sort of a decentralized challenger network because I want to make sure that my rollups are operating correctly. And so, yeah, you can pick and choose depending on your specific scenario or a specific use case. And you could choose all of the three if you wanted. But that's kind of what the design is. It's very modular. And you can, depending on, I would say, specific use case. So DeFi, I would say sequencing might make sense. Faster finality might make sense. But for gaming, maybe decentralized sequencing may not be a huge fit for you.
And with faster finality, does that relate to bridging as well? So I know that optimistic rollups have a 7-day wait period. ZK rollups have until the proof of the state is actually committed. Does that faster finality piece relate to the bridging?
Yeah, so you could use that for bridging. So if you look at external, so by the way, it will help you with non-canonical bridges. So for example, if you have, let's say, Optimism, you have a basic canonical bridge between Optimism and Ethereum, which is the bridge contract on Ethereum operating Optimism rollup. But then you have external third-party bridges, which are the non-canonical bridges like Hop Protocol, Seller, and what have you, a bunch of others. And some of them actually offer you liquidity. They are basically liquidity-style bridges where, let's say you want to withdraw from Optimism to Ethereum. You have this long withdrawal period which you don't want to go through. And so what you do is you go through one of these non-canonical bridges and you say, look, I want to withdraw. And most likely we'll be in a happy path, so there won't be any problem. And so someone might actually might be open to actually sponsor your bridging, right off the gate. So they would say, look, you want to withdraw $100 from Optimism. I'm going to give you $100, or maybe $99 if I'm going to take a fee. And then once your withdrawal to Ethereum has actually happened after the 7-day, then I'll get my money back, right? That's kind of how these liquidity style bridges basically work. And all they do is essentially they run a full node for Optimism. And so they're basically checking if the Optimism rollup is actually operating correctly. And then they have some sort of confidence that, hey, okay, there's a 7-day withdrawal period, But because we are running full nodes ourselves and everything looks good to us, so the chances that something bad would happen and this withdrawal will be blocked is close to minimal. And so why not? I'm very happy to kind of give you that liquidity. And you could this is where you can use this fast finality. So instead of basically, so imagine this hop protocol. It can maybe run a full node for Optimism, maybe it can run for Arbitrum, but it cannot run for 1,000 or 10,000 rollups that are being launched on a daily basis using OP Stack. So it's not very scalable for a hop protocol to do that. So what they could do is they could tap into something like MAC that gives you faster finality, so they don't have to run a full node themselves. They could say, okay, here's a network that already does that for us, and so we're just going to rely on that. And if something bad happens, then these guys are going to get slashed anyway, so I'm protected in that way. So yeah, you could build external non-canonical bridges using this, or you could external canonical non-canonical bridge could use Mac's let's say Oracle feed in some sense, saying that hey, this block has been finalized by us. Now you can consider this to be final from your point of view as well. So yeah, short answer is yes, you could use this to build non-canonical bridges. But I'd like to highlight that this does not help you directly to bridge from Optimism to Ethereum through the canonical bridge. Because that would need modifying the bridge itself, which is a security thing that we didn't want to touch. So you can't use fast finality for canonical bridge, but you could use it for non-canonical bridges.
Awesome. And I guess just on that point, the slashing mechanism, would you have some sort of module maybe where if someone tries to bridge a larger amount than what they would have staked, is there any way that they could get prevented potentially? Because the value of the transaction is higher than the amount that they have staked.
Yes. Very good question. And this is exactly what I think eigenlayer and eigenlayer team has been discussing for quite a while. I think this becomes even more interesting in the coming days when Eigen's slashing mechanism goes live, where there's this, Sridham kind of proposed this idea of, at a high level, the idea was like, you have to look at what's the volume that gets transacted on a daily, monthly, or weekly basis. And so let's say, for example, this is a very popular bridge, and let's say $1 million of assets get transacted through this bridge that uses this AVS as a security mechanism. Then your stake that needs to be, the security that you need to secure this bridge or this AVS has to be much larger than that. Right? It cannot be lower than 1 million, for example. And so yes, you're right that the amount of stake that has to be in the system has to be substantially larger than what is being transacted on this through this network or through this AVS. But it doesn't necessarily need to be like 1 million times more than that, right? It has to be like if someone tries to, let's say, withdraw or transact, let's say, $1 million, then there has to be enough capacity to handle that and challenge that, and make sure that if that goes wrong, then you will get slashed. So yeah, this is exactly what this eigenlayer security mechanism is, where you have to assess how much security is actually needed, and that depends on what's the volume that's being transacted through that channel.
Mm-hmm. And then on the topic of just some of the other components of the other ABSs, so with Vital specifically, I know that you guys intend to adopt a multi-prover system, so including FOD proofs, including ZK proofs, TE-based proof systems as well. Kind of curious to hear about the intention behind adopting that multi-prover system and any sort of trade-offs or limitations that may exist in adopting this kind of model.
Yeah, so this is again the idea behind this is like you could use, as I mentioned earlier, so you have stage. In order to go to stage 2, you need to have at least 2 different proving systems, essentially, 2 different implementations of your state transition function. So for optimistic rollup, the most obvious choice is you could build a ZK fault proof system. So this and that, we published a paper, blog post back in the day with Risk Zero. A lot of people are now building it, including Succinct Labs have a ZK fault proof mechanism as well. So that's one mechanism. So basically the idea is instead of generating fault proofs for every single block like it happens in classical ZK rollups, you would produce proofs, let's say, anytime there's a challenge. So it's not generated every single time, for every single block, but every single time when there's someone that says, okay, I don't like this block, there's something fishy going on, can you give me a proof? This is when you actually generate a proof. And so for practical purposes, that will never happen, right? Unless there's really challenge. This means that the cost of running this is quite low, right? So instead of running a full ZK rollup, which could cost you, I don't know, hundreds of thousands of dollars per month, a ZK fall proof may cost you, I don't know, $100 a month maximum, basically an AWS node, that's it. And so it's much cheaper to run. So that's, I guess, one good thing. But the bad thing is that you need to have some mechanism to prevent challenges to basically flood you with invalid requests. So what I mean by this is you could have a challenger and he's basically a malicious challenger in some sense. And for every single block, he says, oh, no, I don't like this. Give me a proof. And then it becomes like spamming you essentially for fraud proofs, for ZK proofs, which means that it basically turns an optimistic rollup or a ZK fall proof model into a full validity proof model, which is a waste of resources and cost as well. And so there has to be some mechanism to actually for the challenges to put a stake, and then this way you actually prevent them from spamming for proofs. So that is no one has built that, by the way. I don't think, like, neither Risk0 nor Succent nor us, by the way, no one has built that mechanism to prevent spam so far. So I think that's something that's still missing in the system. The other alternative for the second state transition function proof is TE proofs, where the idea is forget about ZK, forget about fault proofs, just put everything into TE. And if you're trusting the hardware, then the TE is going to generate you proof saying that, hey, this block was processed correctly and this is going to be the final state of the system, and here's a proof, and that proof could be verified on chain. The problem with TE proofs, of course, is the hardware, that you're trusting the hardware. So that's one of the, I guess, cons on that. The second thing is the TE proofs are actually quite long and large, which means that if you want to verify that on chain, it's quite expensive. And so you can't do that for every single block or every single transaction. And so it has to be done periodically. The second, one other alternative to reduce this cost is to use kind of ZKify it. So instead of sending the entire this hardware proof on chain, you basically create a ZK proof of that thing, and then you verify the actual. Instead of verifying the actual hardware proof, you verify the ZK proof, which is much cheaper to verify. And so people are doing this. Automata and a bunch of other TE companies are building these ZKified TE proofs, essentially, that you could use. So yeah, I said these are some of the pros and cons of using these systems. And by the way, all of them are live. So anyone who's building rollups, they could actually use both TE proofs or ZK fault proofs today, literally.
Just a clarification on the first part where you said that there's a combination of optimistic and ZK, where there is no option to challenge the challenger. If the data is all on-chain through these blobs, and I guess that the person that makes the challenge bears the cost, it makes sense if the sequencer has off-chain data and then the challenger makes a request to bring the data on-chain. Then because the sequencer needs to post the transaction data to L1 for everyone else to retrieve it. But then in the case of the data already being on L1 because of those blobs, what would be the spammability of that?
Yeah, so the cost, so the way the way system works is, as a challenger, you say, hey, of course the data is public, right? There's transaction data there, the state hashes are there. So as a challenger, you're challenging that if you were to run these transactions, you would not get that state. That's kind of basically what you're saying, right? And I'm just malicious and I'm just having fun, and I would say, you know what? I don't think this is valid, even though it's actually valid. I'm just saying that if you were to run these transactions, you would not get the state. And so I just press a button and say, and by the way, it will just be a on-chain transaction, so it's going to cost you maybe, I don't know, $1, maximum $10. So I'm going to make a request on chain saying, hey, you have to give me a proof because I don't like this state that you posted. Now, the cost is not on the transaction posting part in the ZK fault proof. It's the proving part. And the provers are expensive. So the prover has to go and do the ZK proof of that, and that is going to cost him at least $1,000. And so as a challenger, I'm forcing you to invoke your proving capabilities. And that is expensive. And so I could do that just by sending a simple transaction on chain, which will cost me, I don't know, $1 maximum. And you'll be forced to do, I don't know, maximum, at least $100 compute for that. And if I can keep doing that for every single transaction, then it's like I'm burning your resources. So that's the point.
Got it. What if the challenger has to supply the proof so that they have all the on-chain data and they run it through the... Okay, I guess in this case, the sequencer would be entirely responsible for generating the proof. I guess if we want to take this hybrid approach where they have to say it is fraud and provide a proof that it is fraud.
No, you're right. So there are two mechanisms. One is where you ask the challenger to put some collateral, or the mechanism, okay, maybe you don't need a collateral, just bring the proof yourself. So if you don't think it's correct, show me a proof that it's actually what would be the correct thing. And so you're right. Exactly.
Okay, thanks for making that differentiation, Amrit. And also curious to hear a little bit more about the developer experience for AVS Builder specifically, because I know that AltLayer also has a platform, Wizard, that helps out with that. So wanted to hear more about some of the challenges that AVS Builders currently experience right now, maybe some gaps that exist in current tooling and what Wizard offers to them.
Of course. So for context, we have been very active in the ILA space. We launched 5 marks, the first finality layers. So we earned quite a bit of experience in building these AVSs from scratch. And there are quite a few challenges, which is like, one is ILA contracts are changing quite rapidly. So for example, there were some base contracts initially, and then the rewards are coming, the slashing is coming, and so on. So it's quite complex. And if you look at some of the contracts, you actually have to build quite a few things. So if you're an AVS builder, you have to deal with 2 different things mainly. One is the on-chain components. So these are basically contracts that you have to write that would handle, for example, operator registration. So how does an operator actually register to become a service provider for you? How does slashing happen? How does reward happen, and so on? And when the operators actually give you attestation, how does that get aggregated in a single transaction on chain, in some sense? So these are a bunch of on-chain things that need to happen. And then there's an off-chain component, which is basically the software that the operators have to run for that service. So for example, let's say you are running a ZK coprocessor. So the operators have to run some sort of a ZK proving thing, right? And so that could be the off-chain component. And what we realized is when building these 4 or 5 AVSs, it's not so straightforward for people to actually navigate through the different pipeline of things that you have to go through, especially the on-chain components. So that's the building part. The second part is this social part, which is, let's say you have built all the code. So you have the on-chain component, the off-chain component. You still need the operators, right? Because otherwise, who's going to run this? And so you need to go and find these operators yourself. So what you do is you go and maybe go to the AltLayer app site, and then from there you find all these operators and find a way to contact them. It's also time consuming. And so the idea with Wizard was, can you make all of these processes simple or as simple as possible? Of course, we can't help you with the off-chain component because this is very custom, depends on your business logic. So let's say you're running a ZK coprocessor, your client code will be very different from what let's say Chainlink like AVS would need. So that we can't help you, but the on-chain components are somewhat similar. And so the idea was that we will give you a framework or at least a dashboard from where you can pick and customize some of the on-chain components. And then you would pick and choose which operators you want to serve you. And then we would handle this operator onboarding for you. So you don't have to spend time and money and resources in actually onboarding these operators yourself. So that's kind of the idea behind Wizard. And we feel like it can actually help some of the newer AVSs that are coming up that haven't actually dabbled into how AVSs work. I think I do believe that I can save quite a bit of time and resources for them if they're getting started. And of course, it's also good for experimentation, right? So imagine you're not that deep into AVS quite yet, but you actually want to build something quickly. Let's say, I don't know, you had a quick idea and you say, okay, does it even make sense? And you want to actually experiment that quickly. And that is kind of what Wizard can help you with. So it helps you with quick innovation, quick experimentation, so that you can actually come to your ideas or go to production quite quickly and easier, in an easy way.
Got it. So users can like pick and customize certain on-chain components and then also choose the operators, but then AltLayer helps with the onboarding of those operators. Okay, got it. Yeah, thank you. Also curious to hear more about some of the use cases as well. So what are some of the types of applications, use cases that can be extended with AltLayer's rollups, or some that you're very excited about right now or excited to see in the future?
Okay, I'd say most of the rollups today, they kind of look all the same in my opinion, right? And some of the stacks have kind of increased that likelihood, right? Previously, you were to go and build your own L1, so you had to put some effort into it. There was some reasoning behind. Okay, I need to build my own chain, so there was a lot of thinking that had to go. With all the stacks that are out there, it has become, I don't know, 100x easier to launch chains, which means that many of the chains actually look and feel more or less the same. And so I do feel like there has to be, people need to come up with better ideas on, if you're building a chain, you have to come up with, okay, this is something that actually is different in my chain that is probably not possible or not available in other chains that are out there. And so AVS was that angle for us, right? We felt like, okay, if you're building restate rollups, that something would be could help you differentiate in some way in terms of decent sequencing or faster finality and so on. But in the end, I don't also feel like in the end it's all about applications. You have to come up with an actual chain that kind of makes sense in a specific context. And this is, for example, where we fiddle with this idea of ephemeral rollups, right? Where rollups, you have rollups that kind of exist, but they exist only for a while. And then after that, they basically disappear, or you basically get disposed of in some sense. And it can make sense in the gaming context. So for example, let's say, or ticketing context. So imagine, for example, let's say Adele or any big singer, right? And they want to host a concert and they want to sell the tickets on chain. You know that this event is only going to last for, I don't know, a month. Like the ticket will only last for a month maybe. And so if you're doing on-chain ticketing, there's no point in having a chain serving this ticketing system for more than a month, because when the event is over, there's no point, right? And so in that sense, it actually makes sense to have a rollup that only lasts for a month, and after that it basically gets killed and destroyed. And so that kind of made sense. It also made sense, for example, in context of games, right? If you're building games, of course there are games like, I don't know, Counter-Strike and all the classical games that have people play for years and years. But then most games have a very short lifespan. There's like people play it for like maybe a month, maybe maximum a year, and after that, kind of the interest dies away, right? And so this is again where it would make sense to have a chain where you run your game, and then you would host all your NFTs or assets on that chain. And once you feel like, okay, the game is dying or user interest has gone down, you would basically kill that chain. All the assets will move from this rollup to your base chain, let's say Ethereum. And then tomorrow, when you go back to your drawing board and say, okay, now we have to go and launch my new fancy game, version 3 or whatever, you bring that game to a new chain and bring all the assets back from Ethereum to this chain. So I think this is where ephemeral rollups kind of make sense. But you could imagine other weird or interesting ways in which rollups could be used, and I'm hoping to see some of those interesting examples rather than vanilla OP stack being deployed in different contexts.
That's actually a very exciting development. It's like a state channel type style.
Yes.
And then in terms of the UX, I know there are these emergency withdrawal mechanics. So like, assuming that it is a true L2, you make that withdrawal transaction, you think that the UX would be expensive to move everything, all the assets to the L2. So I guess in this case, do the users make this withdrawal transaction, or will the system make it for them?
Yeah, so the two ways in which you could do it. I mean, one is like the user way, which is user pushes the transaction, but of course you cannot rely on users, right? A user may have transacted on the chain, may have just forgotten about it, right, and doesn't care anymore. Maybe he bought an NFT on that chain, but the NFT has gone to zero, and so he doesn't care anymore, right? And so so we felt like there's a better way, which is like you have to do it on behalf of all the users. So basically, you would bridge everything from that chain, from that rollup to Ethereum in one batch or many batches, but you do on, instead of user doing it. So there will be like a system admin or something, whatever you call it. So the rollup will itself do it rather than users doing it. So it's kind of like closing a channel where the system automatically closes a channel after a while. So it's in a way it's kind of like HTLC, hash time log contracts, where like the system automatically closes after a while if you don't interact. So it'll be something like that. But yeah, I don't think like giving this. I mean, I see the point, but like from a user perspective or from practical perspective, it's a bad idea to give users this flexibility. I don't think they will do it, and if they don't do it, your chain is always in limbo basically, and it will be stuck forever, and that's not the point.
Yeah, I know, like DYDX, they switched and they included that withdrawal mechanism, and the users needed to withdraw manually. And I think it makes sense to demonstrate the withdrawal mechanism, but then on the user's perspective, the UX of that is that they pay the on-chain transaction cost.
By the way, this happened with Gitcoin as well, by the way. So Gitcoin had a chain, and I recall they wanted to shut down the chain because it didn't pick up, but there were FUDs there, and people were not moving out, and so it was basically they had to pay the sequencing fees and everything to Ethereum just for the chain to be operational so that people can actually withdraw. And so yeah, this is a good example of where your user experience, and I mean giving this flexibility to user will actually ended up becoming a pain point in shutting down the chain because it was impossible to shut it down at that time for Gitcoin.
Got it. And scoping out a bit, I'm wondering if you can speak a bit about how you envision AltLayer evolving in the next couple of years within the rollup landscape, or maybe like before we close up, if you have any sort of announcements you'd like to make, any advice that you'd like to give to the audience as well, or any kind of final thoughts.
Yeah, sure. So of course, we are in the hosting business quite a lot. So we, of course, on the RAS side, we host sequences and on all the rollup components. On the AVS side, we run a bunch of operators. We help you host some of these operators ourselves. Nowadays, we are exploring what we can do in the agent space. It's pretty hot. Of course, one angle is verifiable agency. So imagine you have these agents like AIXBT and whatnot. How do you actually know that it's not a human behind the scenes who is typing things on Twitter, and like what's the proof of that? And so the idea is, can you actually run these agents in a verifiable setting to give you some sort of proof that it's actually an agent and not a human? Because by the way, many of these agents are now becoming KOLs. Right? You could look at AIXBT and some of these agents, like people treat them as influencers in some way, and I think that's going to happen where some of these agents will have so much power that they will dictate how well a token does, like it pumps or dumps, right, in certain ways. And so it becomes even more important to actually know that these are actually autonomous agents and not a human sitting behind and kind of pushing the buttons. And so the idea was, how could you actually bring verifiability to these agents? There were some attempts in the past, like ZKML, OPML. Unfortunately, that didn't pick up. One, because of cost, and the second thing was it was not like it worked with smaller models, but it definitely would not work with larger models, like some of the larger language models that we are used to today. And so we felt like one way to do this is through TEs. So again, if you trust the hardware, then you could run these agents in a TE, and then you would get a proof saying that, okay, this is if you made an inference request, and here's the inference, and this is the model that was used, and the agent was not modified or tampered with. And so that gives you that guarantee. So we are kind of exploring that space with this new product that we call Autonome. It's already live, by the way. We're still kind of building it, but it's parts of it is already live for people's experimentation. But yeah, the idea is we're exploring what we can do in that space, especially to verifiability, and then maybe at some point there'll be some sort of ABS angle to that as well.
Got it. So very, very exciting time. And I appreciate all the insights as well, and enjoyed a lot about hearing all the different, especially like the customization options and specific options for developers to choose with the RAS model, with the modular AVS components within the Resig rollups, even within Wizards. So really appreciate all of the insights there. And thank you so much, Amrit, for joining us today.
Thank you very much for having me.
Yeah, thank you.